We now know how the properties of a gas are linked. So now let's look at combining pressure, temperature and volume as we look at the combined gas law. So this is what we're going to be doing today. So they're looking at the combined gas law and looking at some practice questions. And yeah, as always, remember to download your free PDF so you can be making your own notes as we go through today's lecture. Okay, so on to the combined gas law. So we know from previous video that pressure times volume equals a constant. We also know that volume divided by temperature also equals a constant. So we can combine those two equations to give us this equation here. So PV divided by T now also equals a constant. We can also do this. So we can just link the two, well, we can kind of put two together. And then yeah, from this, if we know all of this and say two things over here, we can kind of figure out the final missing value. So it's a very easy, very straightforward equation to use. The only thing to remember is that temperature has to be in Kelvin. And then pressure can be whatever you want, but usually it's going to be pascals as long as it's the same on both sides. And volume again can be whatever you want as long as you use the same units for volume on both sides. And then the final thing to remember is that this equation only works if you have an equal number of moles, both at the start and also at the end. And the gas that you are using is an ideal gas. But as we learned from a previous video, basically all gases are ideal. Okay, so now let's put this into practice. So we've got some practice questions. Well, in fact, it's only one practice question because it is very straightforward. So here is our question. So if you collect an ideal gas at 0 degrees Celsius and 100 kilopascals, it would have a volume of 50 centimeters cubed. So what would the volume be if you changed the temperature to 60 degrees Celsius and 108 kilopascals? Well, so first things first, we are putting our numbers in here. So the only unit we need to change is temperature, so converting that to Kelvin. And then here are the final numbers. And then again, converting it to Kelvin. So once we've got that, we are putting our numbers into the equation. So it's pretty straightforward. So 100 here, 100 here, got the 50, got the 50, 75, oh sorry, 273, 108, and 273. And then we're going to rearrange it and then solve for our missing volume. So nice and straightforward. Once you put all the numbers in, you're going to get an answer of 56.5 centimeters cubed. And again, because our start volume was centimeters cubed, our final answer has to be in centimeters cubed. And as this is to 1 decimal place, then our answer is to 1 decimal place. Very simple, very straightforward, I hope. Okay, so stick around for the next video. So that's going to be on the ideal gas equation. So a little bit trickier, but nothing too hard. And thank you as always for watching. If you found this useful, please tell all of your chemistry friends, like and subscribe for more content, and I will catch you in the next one. See ya.